Namaskar, good morning. Today I propose to deal with 9-point Euler-Feuerbach circle. Okay, excuse me for some mistake there. It is Euler, not Euler. Okay, now let us take the first note of that. See, I have put a note here as to what this 9-point circle is. It is known as Euler circle or Feuerbach circle. These 9 points are midpoints of 3 sides of the triangle, the feet of 3 altitudes, where the altitude intersect the side, and midpoints between orthocenter, the intersection of the altitudes, and each vertex. The center of 9-point circle is of a triangle, also known as 9-point center, is the midpoint of line segment connecting triangles orthocenter, that is, the orthogonal lines meet there, and circumcenter, that is, the point through which we can draw a circle passing through the 3 vertices of the triangle. It also lies on Euler line along with orthocenter, circumcenter, and centroid. Okay. Let us see these things one by one. So I'll remove this note now. Now, first step I take is we are going to take one triangle ABC. Please choose an acute angle triangle, as for obtuse angle triangle, some of the points lie outside the triangle and hence we won't get 9-point circle. So I am taking one obtuse angle triangle ABC. This particular triangle has the segments AB, BC, and AC. Now, second step I am taking is I am going to get the orthocenters. For that, I have to drop normals from vertices to the opposite side, say from A on BC, B on AC, and so on. So let us drop those normals. Now the cutting point also I am marking here, G, next is H, and third one is I. So now I have got the orthocenter, orthogonals and their cutting point to the side, and cutting point all these 3 lines, that is orthogonal lines, is the orthocenter. We have to check that orthocenter is inside, and that is why we have taken the acute angle triangle. So I have marked this orthocenter as J. Now we will go ahead and we will get the midpoints of all 3 sides, that is AB, BC, and AC. So I got these D, E, F as the midpoints for AB, BC, and AC. Next step is mark the centers of segments from vertices to orthocenter. See, I've got this AJ, then BJ and CJ. I have to get the centers of these things. So I got K, L, and M. And please note that I have all the 9 centers ready with me, but I have yet to get the center of all these 9 points. So we have to get O, the centroid of the, by centroid command we can get that. See, I have got the centroid here. Then I locate the center of circumcircle. You know, for that I have to draw the perpendicular bisectors of the 3 sides. I've got a tool for getting perpendicular bisector. So I get that. Right. So I have got 3 perpendicular bisectors, and intersection of that is to be located. Okay, that is known as center of circumcircle. I have got that as P. And now the PJ is marked, and we'll get Q, the midpoint of PJ. I have marked PJ and I have got the midpoint. Okay, and please note that this particular midpoint we can draw the 9-point circle with center Q and radius QD or QA or not QD or QE, etc. Whatever 9-point is there, you can select one of those, and we get the 9-point circle. You got the 9-point circle. Okay. Please note that we have got the 9-point circle in 9 steps only. And in 10th step, I am also giving bonus as the circumcircle. Okay. So please note that we have got the 9-point circle. And as we said right in the beginning, that we have to take the acute angle triangle. Otherwise, you will see that this particular point J will lie outside, and then you may not get all the 9 points defined. So that is why we have to get the acute angle triangle. We'll run the quick review of that. So what we have done is we have taken a acute angle triangle, you see, and then we have got the orthocenter, we have got the centroid, we have got the circumcenter. We joined these things, that is P and Z. We took midpoint of that, and then through that we draw this 9-point circle. Okay. So I hope you like this. Please subscribe to my channel. I'll be posting many applications of GeoGebra also, and the coaching of GeoGebra also. Have a look at the triangle family, quadrilateral family, etc. on my YouTube channel. Thank you very much. See you again.